Welcome in Dark Core. NASA's Voyager 1 is about to achieve one of the most symbolic milestones in the history of space exploration. Launched in 1977, the probe has traveled farther than any human-made object. And by November 2026, it will reach one light day from Earth, the distance light travels in 24 hours. At that point, a radio signal will take a full day to reach the spacecraft and another to return. In this video, we'll explore what this milestone represents, what Voyager 1 is still teaching us, and what lies ahead. Let's get started. The journey to a light day. Voyager 1 was launched on September 5, 1977, just weeks after its twin, Voyager 2. Both missions were timed to exploit a rare planetary alignment, enabling a sequence of gravity assists using the pull of Jupiter and Saturn to slingshot the probes toward the outer solar system and beyond. After completing its planetary mission, Voyager 1 took a faster, steeper trajectory out of the ecliptic plane. It now travels at about 38,000 miles per hour, or 17 kilometers per second, fast by human standards, yet a crawl compared to light's 186,000 miles per second. Over the decades, this steady motion carried Voyager 1 into unexplored territory. In August 2012, it crossed the Heliosphere, the outermost boundary where the solar wind gives way to interstellar space. That moment marked humanity's first step beyond the sun's influence. Today, Voyager 1 sits roughly 15.7 billion miles from Earth. By late 2026, it will surpass 16.09 billion miles, the equivalent of one light day. This distance isn't just a number, it defines the limit of real-time communication. A single exchange with the spacecraft will require 2 full days, one for the signal to travel outward and one for the reply to return. NASA's Deep Space Network, composed of massive radio antennas in California, Spain, and Australia, monitors Voyager's faint signals. By measuring minute Doppler shifts, engineers can determine its exact velocity and distance with remarkable precision. The one light day milestone serves as both a scientific and human achievement, a quiet reminder of what sustained effort can accomplish. Voyager 1's mission was expected to last 5 years. Nearly 5 decades later, it remains active, transmitting faint whispers of data from the cold frontier between stars. What Voyager 1 is still teaching us? Although far from any planet, Voyager 1 remains scientifically productive. Its instruments continue to record the density, temperature, and magnetic structure of the interstellar plasma surrounding it. When it first entered interstellar space, scientists expected a calm, uniform environment. Instead, Voyager detected a surprisingly dynamic region where solar storms and magnetic fluctuations still exert influence billions of miles from the Sun. This discovery reshaped our understanding of how the heliosphere interacts with the broader galaxy. The probe's plasma wave instrument has revealed pressure waves from solar eruptions propagating far beyond the heliopause, while its cosmic ray detector continues to study high-energy particles that originate outside the solar system. Together, these data help refine models of how energy, radiation, and magnetic fields move through the interstellar medium. Voyager 1's resilience has also turned it into a lesson in long-term engineering. In 2017, NASA reactivated backup thrusters that had been dormant since 1980 to correct the spacecraft's orientation. The maneuver succeeded at a distance of more than 15 billion miles and extended the mission's life by several years. The probe's greatest constraint is power. It relies on a radioisotope thermoelectric generator, RTG, which converts the heat of decaying plutonium into electricity. Each year, output drops by about 4 watts, forcing NASA to shut down non-essential systems. Eventually, even the communication transmitter will no longer function. Still, as of 2025, Voyager 1 continues to collect and send valuable data from a region no other spacecraft has reached. It acts as a single point of truth for studying the edge of the Sun's influence, a natural laboratory for testing how stellar winds interact with the interstellar medium. Even with diminishing power, the remaining sensors, particularly those for cosmic rays and plasma, keep producing scientifically useful readings. Every signal that returns from that distance reinforces what the mission has always represented: persistence, precision, and a willingness to keep listening, no matter how faint the reply. Implications and what comes next. Voyager 1's upcoming milestone illustrates the scale of interstellar communication. At one light day away, engineers can no longer make quick corrections. Each instruction must be planned days in advance, and every response takes nearly 48 hours to confirm. It's a slow conversation across time and space, one that depends entirely on patience and prediction. NASA expects to operate Voyager 1 for as long as it can power at least one instrument. By around 2036, its energy output will drop too low to sustain communication. When that happens, the spacecraft will continue its journey silently, drifting outward at about 3.6 astronomical units per year, roughly the distance from the Sun to Jupiter annually. In about 300 years, Voyager 1 will reach the inner edge of the Oort cloud, the vast region of icy bodies that forms the solar system's outermost boundary. Passing through could take another 30,000 years. Beyond that lies open interstellar space, where the spacecraft will travel indefinitely, its trajectory unchanging unless influenced by a distant star. Its path currently points toward the constellation Ophiuchus, and around the year 40,272 AD, it will pass within 1.7 light-years of a star in Ursa Minor. By then, it will have long ceased to function, but its endurance will remain a marker of human exploration. Inside Voyager 1 is the Golden Record, a copper disk containing sounds, images, and greetings from Earth in 55 languages. It was designed as a time capsule, a message to any civilization that might encounter it. Even if it's never found, it symbolizes humanity's curiosity and intent to connect beyond its own world. Voyager's mission continues to inform the design of future interstellar probes. Projects like NASA's Interstellar probe concept build directly on its legacy, aiming to study the heliosphere's outer limits with more advanced instruments and power systems. In practical terms, Voyager 1 demonstrates how human-built systems behave over decades in deep space, how electronics, propulsion, and communication endure in an environment colder than -200 degrees Celsius. In symbolic terms, it reminds us that progress in exploration isn't measured in speed, but in persistence. Voyager 1 endures because it was built to last, and because humanity never stopped listening. Outro. Voyager 1's journey continues in silence, one light day from home. Its signal fades, but its legacy endures, proof that human curiosity travels farther than anything we've built. Thanks for watching Dark Core.